Hello gamers, this is Budrich. This is what I got now. The snake is green, and look at the apple. It changes color when I move here, and when I eat the apple I now get score, points, and also the apple counter increases here. So if we eat this apple, whoa, lots of points, 1200. So depending on the color, we get different amounts of score for eating the apple. And that is what we are going to do in this video. Add a scoring system, changing the colors of the snake and the apple. So yeah, let's start. Let's change to our branch, git check out demo. Execute snake. This is where we left off. Boring, no color on the snake, same color on the apple, no score, no apple counter, no fun. We got some work to do. We can start by making the snake green, because that's easy, you know. Here we define the C red is a variable containing the escape code produced by tput for a red foreground color, and the F here stands for foreground color. Now I don't really remember what green is, so we can dirt hack this a bit and do. If I do this, there we can see the apple is now green because this C red now overrides this one, and set AF2 will be green colors. We can change the name of this variable to green, and then we can just do the same as we do with the apple. We do it with the snake here now, and just add a character like that, and then we change the color here to green. And now we have a green snake and a red apple. And to be honest, it actually makes the game a little bit more fun, just doing this. There, nice. Okay, then let's add an apple counter and a score counter. And we do that in our play area function here. And I think I want to remove the banner here as well. It's getting old. So score colon, and then we just add an uppercase letter here for this special score location. And since we are already using S and E here, we cannot use S again, so we have to we take P for points, and then we can do one for apple A, because we have removed the apple position now, since that is automatically generated. So we can use these two uppercase characters, and they will automatically be added to the position array. Then I also figure out here how to fix this. All we had to do was, didn't work when I had the uppercase L first here. Instead we do L, like lowercase l, uppercase L, and then height width. I think this will work. There. Score apple. We can initiate those to just 0 here to start with. And we can do that somewhere like here. We can take this guy, and then we set PY for points Y position, points X position is equal to, could just do this 0. We can do it for apple also while we are here. And it didn't work, of course, but we got score and apple here, but it looks like it didn't add it to, we're not using the, have to use the pos array. There, now it should work. 0, 0. And just to make it clear here that we can now add stuff to this these special locations. I think it's nice to have the score like printed padded with zeros, and we can easily do that with printf. And then we normally we print %s, you know, and then a string. And this would work, of course. Now it will just print a 0 there. And we can make this string a certain length if we wanted to. We could make it like 6 characters wide. And then it would look like this, you know. But default it pads with spaces before the string. You can also use minus to have it pad with spaces after the string. But you can also, instead of using S, using D, and that will print a digit, a number. And then you can also use pad with zeros. So 0, 6, for example, that will now print 6 zeros here. And if the number would be something else like 255 or whatever, it will look like this. And I kind of like this. The apple, though, that's okay, that can just be a single digit. Right, we got that. Then we add some global variables here. In the main function we declare them as integers. Score apples. And to update the apple counter, we do that every time we eat an apple, and we do that here, new apple. We could do it here. We can just do this quick way of incrementing the apple variable, and if it's not set, it will default to 0 and increment 0 with 1. So this will work. And then let's see here. Here we echo OP, so we just do OP apple. Apple counter is at 0. I eat an apple. Everything fell apart. Yeah. Apples should be the... No. And apples. Sorry. There, apple 1, apple 2. So now we got a counter here, so we can keep track on how many apples we have eaten. That is maybe some information that we don't need in the finalized game, but it's good to have it now, because we will kind of do stuff depending on how many apples we have eaten and stuff later. Okay. Then I would like to add this effect that changes color of the apple, and also like a score system that also changes depending on the color, and the color depends on how old the apple is. So we create a function called oldapple. Since we got the new apple function, now we also got the oldapple function, which is a function that will make the apple older. Bin bash old apple colon. There, we got the function here. And we make the apple older every time we move the snake. So yet again here in move, and we always do this. So we can do it here, for example. We call old apple. And that also means we need to we create a new variable that keeps track of how fresh the apple is. So I like to call it freshness. And when we create a new apple, we set freshness to 41, of course. This is one of the few times where I will use a magic number like this, but we do that here. I will explain why soon. And old apple will decrement freshness. Minus minus. Maybe we could add the freshness counter to the UI also here, so we can see that. Fresh F all right, old apple, and then I guess fy fx freshness. All right, we just echo that out here now for now. So now we don't have any value here at all, because we get that when we call the old apple function. So as soon as I move the snake here, now it's 40. It started at 41, it decremented with 1, and then it prints the new value here. And for every time I move the snake, the freshness counter drops. And it will eventually be a negative number. And it also looked weird there, because this is where you need to keep track of the size of the string here and use printf. Because look at this now, when we eat the apple here, it will reset the counter to 40. But instead we will get weird results like this now, because it doesn't remove the old digits. That 9 there, it will just stay there forever now till we overwrite it with a new 3-digit number, including the minus. So we also add a printf here. Printf percentage, and we can do -5 or something. D freshness. There. And now we should never get a problem. And it will also work for like single digit numbers now. Fine. Whoops, I killed myself. It works. Good. Okay, so depending on the freshness, we change color. And my thought here is that we can have 4 different stages of the apple. And every time we get to 40, 30, 20 and 10, we change color of the apple. And that's why I wanted to start at 41. So we could actually make a test here, and we can make this really efficient if we want to, and of course we want that. If we change position here of minus to here instead, we will see no difference at all. But it actually makes a difference, because now we can do this. If minus freshness is more than 9, because we want to test here at 10, 20, 30 and 40. So there's no need to do any test, change any colors if it's less than 9. And we also want to see that freshness modulus 10 is equal to 0, which will be true for 10, 30, 20 and 40. But here, if we want to be even more, make this even more compact, because 0, when something is 0, it's automatically false in a math test like this. So this would evaluate to false on 10, 20, 30, 40. But then it gets a bit weird here, because what we want to do is something like, if this is false, or do something here. But that gets a bit weird with the and at the start here. Maybe it kind of works, but we even get an error here from shell check. So what you really want to do when you got a situation like this is invert this test here. So if freshness is less than 9, if that is false, or continue with the next test. And then it tests here if this is false, which it will report if the sum here is 0, or do things. And the things we do is changing the color, because now we know we have a value that is 10, 20, 30 or 40. And we can easily do a case here now. Case freshness in 10, do something, 20, 30, 40, esac 20, 30, 40. Create a local variable called a. And a will contain a new apple for us. So what I will do here now, we'll cut this stuff here, and then we just add a @ symbol here instead. And then in oldapple, do this, a is equal to, and now we need 4 different colors. I don't think we got that here now. We need more colors here. Maybe we should add it here again now. So C red, we know that green is 2, 3 is yellow, yellow, 4 is blue, red, 5 is magenta or purple. Let's call it magenta, even if it is purple, whatever. And then I know that 6 is cyan, like a light blue. There, now we got a lot of colors here. Change this back to oldapple. So the lowest hanging fruit that could, I want that to be yellow or brown. And then instead of printing the @ symbol, we print our apple variable here now, because that contains the @ symbol, and that means now we can change the symbol for the apple, but the colors will still work here in this function here. And now we just add different colors for the different value here. So 20, I don't know, maybe that's a blue apple. And then we can have a magenta apple, and at 40 we have the red apple. Then we can also add a OP local variable here, and do OP plus equals one of these, but here now we print our new apple A, and we want to print that at the apple position, and we got that, you know, packed in apple P, like this. So we have to unpack the X and Y positions here. Maybe it would make sense to, yeah, it probably would do that, to store apple X and apple Y, so we don't have to unpack it every time we change color here. That would be smarter to do that. So let's do that. We define them as global variables here. Apple Y, Apple X. And we get a new Apple position where we create the apple. X is equal to X and apple Y is equal to Y. And then we use them here. Like that. Add the freshness to the OP variable and then print OP. Alright, let's see if this works. Now the apple is black because that's the default color now. We don't have any escape codes at all when we first print the apple. But as soon as we start moving the snake, the freshness will be 40, you know, because it starts at 41, but then it calls oldapple, decrement freshness with 1, and it will be 40, and it should set the apple color to red. And it did. Let's see if we change here at 30. Magenta, purple, purple apple, blue apple, blue apple, yellow apple, eating it. Yum, yum, yum. Okay. But we don't want the black apple initially like that either. And what we actually can do now is, because we print the apple and everything in this old apple function. So we could actually call old apple from new apple as soon as we have created the positions and everything. So instead of printing this stuff here, we just call old apple. And now it should immediately start here at fresh 40 because it have called old apple and we got the red apple and everything. It's nice and it changes colors. So nice, so good. Right, now we also want some points, score. Yeah, I can see I got update score here. So yeah, here is that function. Thought I had removed it, but I hadn't. Here we can see in update score we have a local variable toAdd, and toAdd is equal to, and then I do one of these ternary tests here to see if freshness is less than 10, then the score is 40. If it's less than 20, it's 100. If it's less than 30, it's 600. Otherwise you get 1200. But then we also multiply this score we get here, 40, 100, 600, 1200. We multiply that with level plus 1. Right now we don't have any levels. We will add that in the next video. So level here will be 0. So it will just multiply toAdd by 1, meaning we will get these scores. And the reason I'm using these scores is because that's the same scores I was using in Tetris here. And those scores, I have copied them, and this system by multiplying with the level plus 1 and stuff, all of that is copied from, or cloned, I guess I should say, from the NES version of Tetris, which I am addicted to. And I think it's a well-balanced score system, and I hope it works fine in Snake here as well. So all we need to do here now is update the score when we have eaten an apple. Should also create the score variable here out in the main function to make sure that it is or we even have that also here. We are, yeah, whatever. If it's there, you know. I guess I created it in the beginning of the video maybe. Alright, we got the score variable. and in update score we update this variable. That's what we are doing here. So it store the result here of 2add times the level and adds that to the current score variable. So all we have to do is execute update score. And now we have to make sure that we do this update score before we create a new apple. Because in new apple it will reset freshness to 41. And if so we have to be sure that we update the score before we reset that, because we need the freshness counter to determine what score we want to print. And then we print add score here to our output variable at the py for points and px. And here we should also use the printf function that we initialized with play area. Got it here. I think we can even do this. Print score here. I think that will yield, or we can even do this, I guess, to be sure that it's 0 or whatever. Let's just print 0 here. So now it will start with 0 instead of 255 there. Move. This, but we don't have to do that. There. Okay, we eat this apple. 1200 points, because it was red. And we can see here now that a purple apple, that will give us 600 points, I believe. 1800, yes. And this blue apple, that's 100 points. And let's test a yellow apple. That should give us just 40 points on level 0, which we are playing at right now. And it works. And everything here now works. And I think I'm fine with that. One last thing here is that I figured out why I wanted to show you these random seeds and stuff in the last video, and it didn't work. And it's because we are using random inside a subshell, which we do here now when we call this random in range. And we could instead do this and not use that function, getting the same results. It's a little bit more messy code, but not that much actually. So if we do this instead, then it will not use random in a subshell, and then it will use that the random that we have in our main function, which currently is the process ID. So this shouldn't make any difference at all. We get a random location for the apple every time we start. But now the seeding will work here. If we do 1, 2, 3, it will always start at the same position. You see the apple is always at the same position, and it's even like this. So if I eat this apple, the next apple is there, okay? With the same seed, it will the next random number will also be the same. So this is a way you can replay the same game if you ever wanted to do that in Snake here. But that's how these random seeds work. But it's more fun to have a somewhat more random, unpredictable RNG here. So we use the PID ID for now. Okay, and now the game is almost playable, you know. We get scores, we get different colors, we can die. Now, next video we add levels, and what that means is that for each level the game should become harder, and what that in turn means is it becomes faster. meaning the snake will in the next video move automatically, and for every level it will move faster and faster, and the game will become harder and harder, but the higher the level, the more scores you will get. So just imagine playing on level 20, for example. That would give us 20 times 1200 when we eat a red apple. Quite a big difference. But we take that in the next video. Thank you for watching, everybody. Have a great day. Bye, bye, bye.